All right, guys. So this one is going to be problem 3, example 1. Just like yesterday, you should watch this video and then try example 2 on your own, and then check up front um, for the answer key. Okay, so now let's take a look at this. It says Mitch is driving 32 meters per second at t equals 0. As he slows down to stop at a stop sign, his velocity changes at a constant rate from 32 meters per second to 0 meters per second over an 8-second time interval. So it wants me to make a graph first. So part A says draw the velocity versus time graph for Mitch's car. So first thing I'm going to do is I'm going to label this thing. So I look over here and I see I've already got time is labeled. So that's good. I don't have to do that. But velocity is not labeled. So if I look over here, I see that it looks like my highest velocity is going to be 32. And so over here, let's see how many lines I've got. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 3s won't work, 4s will probably work, but let's just count by 5s. That'll make it easier. So I'm just going to go 5, 10. Let's just do this. Let's make it easier on ourselves. Let's skip every other one. 10, 20, 30, 40, 50. Now technically we should also go ahead and label these as negatives too. Negative 10, negative 20, negative 30, negative 40, negative 50. Now our line's not going to go in there, but that's okay. Okay, so let's find our points now. So I said that at 32 meters per second, that's time 0. Okay, so this right here, that's a velocity. We know that because of the meters per second, and then we know this is a time. So that's a velocity and a time that go together. So when time is 0, velocity is 32. So I'm going to put a dot. We'll do this in, let's say, purple. All right, so I'm going to put a dot right here at 32 and 0. Okay, and then we say that, all right, so he's going to slow down to 0 meters per second, and it's going to take him 8 seconds. All right, so that's my velocity. That's my time. All right, good. So I've got another velocity and time. So I've got 8 seconds and 0 meters per second is right there. I guess I didn't label that 0, did I? We'll go 0, like that. Okay, good. So now what's important here is it also says that it was a constant rate. So if it's a constant rate, that means that this can be a, that's right, straight line. Oh man, that's pretty straight for freehand on the iPad. Okay, so I've got a nice straight line there. All right, so part A is done. Draw the velocity versus time graph for Mitch's car. We can, let's erase some of this stuff just to clean it up. Okay, we can check that one off. All right, now it says calculate the acceleration of the car. Show your calculation in detail. Okay, so we're going to use the equation. This is written on the board, by the way. Okay, we're going to use the equation. I'll zoom in here. All right, we're going to say A equals VF minus VI over TF minus TI. Okay, now what are those things? So I've got VF, VI, TF, and TI. What are those equal to? All right, well, VF, final velocity. So at the end of the motion, he's going 0 meters per second. So that's it. After he's stopped, 0 is the last velocity. Then the initial, we look back up here, well, he starts at 32 meters per second. All right, so 0 is my final, 32 is my initial. Now my final time is 8. All right, and my initial time was 0. Nice. Okay, so now I've got all those. So now I can do VF minus VI, and that's going to be 0 minus 32 divided by, and that's going to be 8 minus 0. 8 minus 0, all right, equals 32 divided by 8. Whoops, that's negative 32. Now remember, that, all right, that is a velocity. So that's negative 32 meters per second, and that's 8 seconds. Okay. And then we'll just punch in the calculator. Now check this out. We'll see if this works for you guys. Look at that. We'll go 32. Does it let me do negative? Looks like it doesn't. Maybe like that? No. Oh man, I messed that up. 32 divided by 8 is, hey, look at that, 4. All right, now it's 4, but remember that's a negative 4. Don't forget that negative. All right, so negative 4, and that's meters per second squared. Negative 4 meters per second squared. All right, nice. So we can check off B. Okay, now let's move on down to C. It says describe 2 methods to calculate the distance traveled by the car. So distance traveled. All right, if we look up on the board, we see that another way to say distance traveled is just to say delta x. So what are 2 ways we can find delta x? All right, well, I know that, and remember, it asks for 2, so just go ahead and number them. So we're going to do 1, and then we'll do 2. So 1 is going to be, the first thing that we learned was to find the area under the line. All right, good. So that'd be one way. The second way would be to use motion equation. Look at that spelling. Number 2. All right, so that's up on the board. Now the tip-off for motion equation number 2 is that motion equation number 2, okay, has delta x in there. So for both of these, we're trying to find delta x. Displacement is area under the line, and then we can also use motion equation number 2. Now, me being the thorough teacher that I am, I'm going to go ahead and use both ways and show you that it's going to yield the same answer either way. Okay, so for 1, let's find the area under the line. So if I look up here, okay, well the area under the line is going to be all of this. So it's this triangle. Now for this one, it's just a triangle. Remember, in some examples, it could be a triangle with a rectangle underneath of it. But now it's just a triangle. So if we think back, how do we find the area of a triangle? Well, area of a triangle is area equals 1/2 base times height. Now if I go up here, I need to find the base and the height, okay? And we're going to look, and we're going to see that the base would be this section right here, and we see that that's 8. And then the height would be this section here, and that's going to be 32. Remember, I got that number right there, 32. All right, so it's going to be, oops. All right, so it's going to be area equals 1/2 times 8, that's my base, times 32. All right. Now what I'm going to do is I'm just going to go ahead, and here's a great way to rewrite this, guys. Think of 1/2 as 0.5 times 8 times 32. So that's 0.5. Because when we put it in the calculator, it'll be easier to do it that way. So I'm going to go to my calculator, and I'm going to do 0.5 times 8 equals, and then we just leave that on there, and we go times 32 equals, and I get 128. All right, so my answer here is 128, and now let's see, that's how far from the stoplight, so how far's got to be a distance, and let's see, this thing was in meters per second, so that's going to be 128 meters. Cool. All right, now let's use my second method. So my second method, we said that was to use motion equation number 2. Okay, so motion equation number 2 says delta x equals 1/2 acceleration times delta t squared plus vi delta t. Okay, now let's see if this thing works out. All right, so I've got to start plugging in, and maybe let's just do this. Let's just say, what are all my variables here? So I need a, I need delta t, and I need vi. All right, well, a, we saw that a was -4. Okay, so a is -4, and delta t is 8 seconds, and vi is 32, because we go back and we look and we saw that at the very beginning, the initial velocity, oh, here we even have it written out, look, vi is 32. And then delta t was this part right here, the change in time. All right, so let's plug this stuff in and see if we get the same answer. I hope we do. I haven't done this yet. All right, so delta x equals 1/2 times -4 times delta t is 8 squared plus 32 times 8. All right, good. All right, so let's go ahead and do. All right, so when we do, remember we do PEMDAS, we do PEMDAS. Please excuse my dear Aunt Sally. Well, there's nothing inside of parentheses to do. Oh, I guess so. There kind of is. Parentheses and exponent are kind of together here. So 8 squared, we can go to our calculator and we can just do 8 times 8. That's 64. Okay, so 64. Whoops. You guys got to see me write that. 64 is what we have there. And then 1/2 times -4 times 64 plus, and then let's go ahead and do 32 times 8. We'll do 32 times 8 equals 256. So I'm going to go 256 there. Okay, now we have to do 0.5 here, so I'll erase that. So this, we're actually going to call that 0.5. Okay, so 0.5 times -4 times 64. So we're going to go 0.5 times 4 times 64. All right, so that's 128, but remember it's a negative. Okay, so I've got -128 plus 256. So what do I get when I do, I wish I knew how to make that thing do negatives. Can I do -128? Hey, there we go, -128 plus 256 equals 128. So delta x equals 128 meters. So look at that, guys. We used 2 different ways to do it, and we got the exact same answer. Yay! Oh man, that's lame. Look, sorry, I didn't realize you guys were on the calculator still. All right, so good. I've got delta x is 128, and I got delta x is 128, and you guys didn't see me write my really cool yay, so I'll highlight it. Yay! All right, there we go.